Hello everyone, my name is Anshu Karmacharya and this is my demonstration for the object-oriented programming assignment. In this video, I will walk you through the key features of Turtle Graphics application that I have developed using Java and the LBUGraphics library. And during this demonstration, I will show both the working application and the relevant parts of the code while filling out the assessment form. Now let's begin. As you can see that I have already entered my student details and my GitHub repository contains all the information of my Turtle Graphics application. Now let's proceed by showing the project setup. Here is my code for the main.java and here is the full code for turtlegraphics.java. Now let's move on to the requirements. As you can see, the first requirement here is LBUGraphics.jar properly added to the project. You can see that I've added the LBUGraphics.jar file properly to my reference libraries. This requirement is fulfilled. The second requirement here is project contains main class.java set up LBUGraph correctly by extending LBUGraphics. So you can see here that in my turtlegraphics.java, I've created a turtle graphic class which extends the LBUGraphics. And in my main.java, I've made an object of this, which sets up the application. The third requirement here is correctly calls the LBUGraphics method and the turtle animation is displayed. So you can see here that I've correctly called the turtle about method. And when you run this, the turtle animation is displayed. Now moving on to the next requirement, mainClass.java has a main method which creates an object of the turtlegraphics.java and then all the further processing is done from this object. As you can see that in the main method, I've created a object of turtlegraphics.java and all the further processing is done from here. So the fifth requirement is the about method is called when the user types about into the text field or clicks the OK button. So the code for the about method is here. And when the user types about, you can see that the turtle animation appears. Now moving forward, this version of turtlegraphics.program includes a variety of core features such as movement and drawing commands, pen controls, color selection, shape drawing, and more. And in this code, the main window uses a border layout. The turtle canvas is located at the center. A scrollable text area is there showing the command history at the left, and a drop-down button to switch personality is located at the top. Then there is a menu bar, and firstly it includes a user manual or help for the user to understand the commands better. Then the menu bar also contains the options like save and load image in the form of PNG and also save and load the commands in the form of a text file. Here is the code for the user guide. Then user commands like forward 100 or left 90 are typed into the provided field and processed into the process command method. And each command is saved to history and passed to process command internal for the execution logic. Then the turtle personality, the turtle responds based on its current personality using personality.getResponse command. So now let's move on to the requirement 2. The first requirement here is pen down command working. as you can see there. The pen down command is working. Yes. The second requirement here is move command works. You can see here that the move command is working. The move command also works with a parameter. The next requirement is reverse command works. So let's set this first. So when we type reverse, the turtle moves back. The other requirement here is the reverse command works with a parameter. We can see that it also works with a parameter. Now, the next command here is the left. It works. The next command here is left. We can see that it works. So the next requirement is left command works with a parameter and can be rotated by the amount type. Here we can see that the turtle moves 90 degrees to the left from its current direction. The next requirement is right command. We can see that it works as well. The next command is right command works with a parameter and can rotate the turtle by the amount type. So we can see that it's to the right from its current direction. So this requirement is done. The next requirement here is pen up command working. This lifts the pen so that the turtle can move without drawing. Here we can see that the turtle moves, but there is no drawing. So this command is done as well. The next command here is at least 4 color commands such as red command working. So let's reset it first. We have to pen down. Then I'm changing the color to red. Any line drawn after this will be in the red color. Now I'm changing the pen color to blue. Then I'm changing the pen color to green. Lastly, I'm changing the pen color to white. So this command is done as well. The next requirement here is the clear command. This clears everything from the canvas and moves the turtle to the far left as per the requirement. Now let's look at the code for this. Here is the case for clear. It shows a message if it has an unsaved work. And over here, this method helps to clear the canvas and move it to the far left. and it faces down, and also ensures that the pen is down. Now the next command is reset. The reset command clears the canvas and returns the turtle to its original position, that is on the center. And now let's look at the code for it. Here is the case for reset, and this reset method, it calls the method clear first, then moves the turtle's X position to the center of canvas by dividing the canvas width by 2. Similarly, it moves the turtle's Y position to the vertical center by dividing the height by 2, and then it sets the turtle's facing position to 0 degrees and resets the pen width to 1 pixel, and then it sets strokes with the help of pen width, and it calls the reset method in the superclass, which ensures any reset logic defined in the superclass is also executed, and it flags that there is no unsaved work, which likely used to track whether the user needs to save their work before exiting or resetting the screen. Now let's look at the code for these commands as well. We can see that this part checks the first word of the command to determine which case to execute. And then if the command is pen up, the turtle stops drawing lines when moving by calling the draw off. Then it breaks. Then the break exits the switch. And if the command is pen down, the turtle resumes drawing lines by moving and calling the draw on. And if the case is move or forward, first of all, this part of the code helps to ensure the distance parameter exists in part 1, that is the command part, and if it does not, then it shows an error message and the processing stops here. And this part tries to convert the distance parameter into an integer. If it's not a valid number, then an error message is shown that the invalid number format. Then this part helps to check if the distance is valid using a helper method is valid distance. If not, it stops the further execution. Then the forward move distance helps to move the turtle by the given distance. And after moving, this part helps to check if the turtle is outside the drawing area, and if it is, it displays a warning message that the turtle moved out of bounds, and it breaks the case for move. Then the default left degree turning angle is 90 degree, and if a value is provided, then it uses that instead. The angle is validated, then the turtle turns left. And then it is the same logic for the right as well. The default turn angle is 90, and if a value is provided, it uses that instead. And it also checks if the angle is valid. If the angle is not valid, it exits, and if the angle is validated, then it turns to the right. The next command here is reverse. This reverses the turtle by default of 50 units if a number is given. It uses that. This also checks if the angle is validated. And the forward method is called with a negative value to move backward. Similarly, the pen width command sets the drawing pen width. If a width is given, it sets the pen width and calls the set stroke pen width. Otherwise, it shows an error. that please specify a width. Then these cases help to set the color pen color to black, blue, green, red, and white. Now let's move on to requirement 3, which shows how the program handles invalid or incorrect input using command validation. The first requirement here is reports invalid command. Let's look at it. Here I'm entering an invalid command. The program shows Here I'm entering an invalid command. The program correctly shows an error message saying that the command is unknown. The second requirement here is detect valid command with missing parameter. Type move with no parameter and it should report that there is a missing parameter. It also gives an error that the move command requires a distance parameter. The third requirement here is detects the non-numeric parameter. Type move xxx with non-numeric parameter and it should report the missing parameter to the user. When I type move xxx, since ABC is not a number, the program shows an inappropriate error. The program shows an invalid number format for move. The fourth requirement so you can pass negative numbers or excessively large numbers. Let's see that. When passing a negative number, it gives a warning that the parameter must be positive because distance cannot be negative. And if we give a angle, so this is done as well. Now let's move on to requirement 4. I'll demonstrate the saving and loading functionality for images and commands. The first requirement here is save command works to save an image. Now let's draw something first. First, let's pen down. Then let's draw a triangle. Now we can save the images by two methods, by typing out the commands here and by going into the file and saving the image. Here we can see that the image has been saved as turtle10.png. Now let's look at the code for this. Here, a save image method is created to save the canvas to an image file. And then this part initializes a counter to create a unique file name such as turtle1.png or turtle2.png, etc. And then this do while loop checks if a file named turtle1 or turtle2.png already exists. If it does, then it increments the number until it finds a free file name. And then it uses Java's image input output to write the canvas image, which is obtained via the getBuffered image as a PNG file. Then it logs the saved image in the history of our GUI as image saved as the PNG. And if it handles error during the save operation and shows an appropriate message as image save failed. Here, the next command is load command work. It loads a previously saved image file and displays it on the Turtle graphics canvas. First, let's clear this image. Now let's load the image we just saved. It asks the user if they want to load the most recent image or they want to choose a number such as turtle1.png or turtle2.png. For now, let's load the most recent image. Here we can see that we have found the image we just saved. Now let's look at the code for the load image. Firstly, we've created a method, load image dialog, for loading the previously saved image. And now this refers to the current working directory, and it finds all the this line finds all the PNG files starting with turtle, which is all our saved images. And then if there are no such files, then it shows an error message that no image is found, and it exits. And if it finds the most recent, if there are no such file, it shows an error messages and exits. And if it finds the most recently modified turtle images, here with recent is equals to f, and it asks creates a choices for the user if they want to load the most recent image or they want to choose an image number. It displays a dialog box for asking the user how they want to load the image. And if the user chooses load most recent, this part loads the most recent image. And if the user chooses image number, it asks the user for the image number. And then if the user typed a number and the file exists, then it loads the image. Otherwise, it shows an error that image does not exist. And if the user hits cancel, then it also shows a message that image loading was cancelled by user. So yes, this requirement is completed. Now the next requirement here is save all commands previously typed as a text file. This command saves the text file typed so far into a text file called commands.txt. Now let's go to the file and type save commands. Here it is shown that the command is saved as command8.txt. Now let's take a look at the code for saving the command. Here we can see that there is a method for saving commands, and it also works in a similar pattern as the save image file. It first initializes a counter, and then to create names like command1.txt or commands2.txt, and then this loop checks if there is a command named command1.txt or command2.txt, and if it does, it increments the number. And again, using the Java's buffered writer, it saves the command as a txt file, and then it opens a buffered writer to the file and writes each command from the command array or on a new line, and it displays the file name if the command saved as file name, which is command1.txt. And if there is an error, it shows the error message failed to save commands. So this part is done. The next requirement here is loads a text file of commands and executes them. Now I'll clear the canvas and load commands from command.txt. Now if I go to the file and load commands, it asks the user again if they want to load the most recent file or choose the file number. So let's load most recent for now. So we can see that it has loaded all the previously typed commands over here. Now let's take a look at the code for loading the commands. We can see here that a method is created, that is load commands dialog. And then it finds all the text messages starting with the word command and ending with txt. And then if there are no matching files found, it gives us an error message that no saved command files found. And if it exits, and if it finds the most recently saved command file, it asks the user how they want to load commands. That is, if they want to load the most recent command or choose the file number, which is command1.txt or command2.txt. If the user chooses the most recent, then it loads it. And if it chooses a number, it attempts to load that file. And after loading, it gives a file command and if there is an error, it shows that file commands.txt does not exist. And if the user cancels loading the image, it gives us an error message that load was cancelled by the user. And if this is the part which actually loads the command from the file, it uses a buffer reader and it reads each non-empty line and sends it to the process command to execute it. Process command to re-execute the lines. And after that, it displays success or a failure to load message in the GUI. And this load image part helps us load and display the image on the canvas, which attempts to load a PNG file with the given name. And if loading is succeeded, it clears the current canvas and it gets the canvas's graphics object from LBUGraphics framework. Then it ensures the image does not exceed the canvas's dimensions. It selects the image down smoothly to fit the canvas, this part. And then it draws the image onto the canvas and refreshes the display. And it handles images or file errors with appropriate messages such as fail to load image is null, or error loading image. So this part is done. Now the next requirement here is a warning is displayed somewhere if the current image is not saved and the display is not affected until the user shows answer. So here, let's draw something. Now if I first let pen down. And now if I type clear, it gives us an unsaved work warning since the image is not saved. And here, let's look at the code for it. Over here, it has a method. If there is no unsaved work, then it returns true. And if there is an unsaved work, it asks the user, if you have to unsave work, do you want to continue without saving? So this requirement is done as well. Now let's move on to requirement 5. Over here, I've used inheritance by creating a subclass of LBUGraphics and overriding or adding new behavior. The first requirement here is override the about method so that it still does the same dance but appends a message that contains your name. So right now, if we So the about method is overridden, and in addition to the usual animation, it also shows my name at the end, and it gives us information about this method. The next requirement here is implemented a square length command. Now let's type a square. This draws a square with each side of 90 units. Let's look at the code for it. Here is the code for it. Now the next command is append red, green, blue command that takes three parameters, one for red, one for green, and one for blue to make an RGB color. This command allows drawing any. This command lets me set an RGB color using three numbers. Let's try. This has set the pen color. Now if I draw a line, it gives me a different color. Now we can try it with a different color as well. You can see that a different color line is formed. Now let's look at the code for it. This is located in the case pen, which means the user wants to change the color of the pen. This part checks if the user entered exactly four parts in the color, which means pen and the three color names, which is red, green, and blue. And this part checks if the number is correct, and this line converts the second, third, and fourth parts of the input from string to integers. RGB will hold the red, green, and blue color values, while integer parse int will throw an error if the values are not valid integers. So this command is done. The next command is a pen width command that alters the pen width for further drawing for all the further drawing operations. Let's take a look at it. Now let's draw a triangle. We can see that the pen width has increased and the drawn lines have appeared thicker. So the next requirement is a triangle size command that draws an equilateral triangle. Let's take a look. First, let's clear this. This draws an equilateral triangle. Now let's look at the code for it. Here is the case for the triangle. And this part checks if the user has provided only one argument after triangle, be which must be there, and it passes the argument as an integer to get the size of each side. Then there is a loop which draws an equilateral triangle by moving forward the size. And turning left 120 degree and repeating it 3 times. In this loop, and this sets a default triangle length. So this is done. The next requirement is a further triangle command with specified 3 sides that draws any triangle. Now let's have a look at this. First, let's reset it. Now let's give the triangle 3 different sides. It draws a different triangle now. Let's have a look at its code. We can see that if this part checks that the user has entered 3 values for each of the sides of the triangle, this initializes an array to hold the 3 side lengths. Then it parses part 1, part 2, and part 3 into integers and stores them in an array. Then it checks the triangle inequality theorem to validate if a triangle is physically possible. If valid, it calls a custom method draw triangle from sides to draw triangle using those side lengths. Then if the sides are invalid, it shows an error invalid triangle violates triangle inequality. Then it handles the case where non-numeric input is entered by giving an error invalid triangle length. So yes, I could do this. Now, let's have a look at this draw triangle from side method explanation. This part of the code extracts individual side lengths from the array and then calculates the angles using laws of cosines. Then it converts angles to degrees from left turns and rounds to the nearest whole number. These are needed because the turtle turns commands work in degrees. Then it enables drawing so the turtle leaves a trail while moving. And then it moves forward by side A and turns left 180 degree minus degree C or angle C to prepare to draw side B. And then it moves forward by side B, which turns left 180 minus angle A to prepare to draw the side C. And then finally, it moves forward by side C and turns left again to complete the triangle's final angle and the reset orientation. So the final requirement here is things that are not specific requirement on the marking scheme, anything else to add. So what I've added here is the turtle personality dot system. I wanted to make the application more interactive and engaging, so I gave the turtle different moods or personalities. These personalities affect how the turtle responds to the user commands, not just visually, but with text-based feedback that changes based on the selected mood. For example, in a sassy mood, the turtle might respond sarcastically when you ask it to move. Or in happy mode, it might cheerfully conform your actions. There is even a Nepali personality, which gives you the responses in Nepali while still speaking in English. I implemented this by creating a base turtle personality class and several subclasses like sassy personality, happy personality, and Nepali personality, each of which overrides the response methods for commands like move, pen up, about, and so on. The user can switch between these personalities during runtime using a simple menu or command. So you can see that there is a drop down menu for the personality, and you can simply click on the personality and click switch personality, and you can see that here the turtle's personality has been switched. This feature demonstrates my understanding of inheritance, polymorphism, and good object-oriented design, and it also adds a fun personal touch to the user experiences. So this is the code for the turtle personality. Now let's look at the further requirements. I've shown this form in the demo, yes. I have put my name and group in the readme.md in the root directory of my GitHub portfolio, yes. I have explained my code in the demo, yes. Yes, thank you very much.